Okay, so good evening, everybody. We are going to be doing 5.3 multiplying polynomials tonight. So it is not going to be a stressful night. But let me start out by talking about math tutoring. Yes, we had a good day. That's my pen. Trying to get my pen to work. Okay, so let's see. Math tutoring. In addition to Zion's hour that he's doing during the week, I think he's going to add a couple of hours to his schedule. In addition to that, the Math Tutoring Center here at Moore Park College is available as well. So this will be Monday through Thursday from 10 a.m. to 7 p.m. They want you to know that they're still open. Fridays they are closed. But they are open on Saturday from 11 a.m. to 2 p.m. And the website to get to the virtual tutoring center is www.moreparkcollege.edu/TLC.
Mr. Gaines, what about for Sunday?
They don't have tutoring on Sunday. So Friday and Sunday, they are closed. Okay, so that covers about all day long during the week. So if you work, at least you can make an hour or two after work during the week. Saturdays is usually pretty light for them, so if you don't work on Saturday, you can get your tutoring on Saturdays. And I hope that we are keeping up with our homework. That's the only way to be successful in mathematics is to keep up with your homework, because that's practice. You have to actually do the problems, work out the problems on your own. So it's not enough watching me work the problems out and understanding it. You actually have to work the problems yourself so it can become a part of you. Okay. All right. So please take heed to the advice. I've been teaching a long time. I know what I'm talking about. All right. So let's get started with 5.3. 5.3. We're dealing with multiplying polynomials. Multiplying. Grab my book real quick. Multiplying polynomials. We are in chapter 5. And just want to check something real quick. I think it was last class. Not sure if it was Joey who asked when we were doing exponents. Were we going to do negative exponents? We actually do deal with negative exponents. I forgot about that. In section 5.5. So we will
Okay.
get the negative exponents. Oh, you're ahead of the game. That's okay. That's all right. All right, so that's next class. All right, so today is just strictly multiplying polynomials. So I don't think you'll be too stressed tonight. I hope not, since it's just multiplying polynomials, but we're gonna do a lot of them. So here we go. So first of all, let's start off with multiplying monomials. Now remember, monomials are one-term polynomials, right? So we basically already done this in section 5.1, but I'll give a two-stepper for these. Multiply, step 1, multiply coefficient with coefficient. And who remembers what the coefficient is again?
Isn't that the number in front of the variable?
Yes, those are the numbers in front of the variable. Good. So multiply coefficient with coefficient. And step 2, multiply same basis. Let's fix that. Same basis using the product rule. So, example 1. Let's just multiply. And what's a base? What do we mean by base?
It's the number with of the exponent. So like if you have 7 to the second, it would be the 7.
Okay, good. So it's whatever's being raised to a power. Okay, good. So let's say we have negative 5x cubed. That's to the third power, right? Times negative 2x to the fourth. What would that equal? Well, step 1 says multiply coefficient with coefficient. So we're going to do negative 5 times negative 2 is going to give us a negative times a negative is a positive, right? Good. And then 2 multiply same basis using the product rule. X to the third times
Won't
x.
that be x7? to the 7th.
Good. Nice, colorful answer. Right. Good. Right. Let's see. B. How about -7x squared multiplied by, oh, let's say 0.2 x to the 5th. Okay, coefficient with coefficient. So -7 is going to get multiplied by the 0.2.
-14.
Is it really -14 or is it negative?
Negative 1.4.
Negative 1.4. Thank you. It's a 0.2. And then the x squared times the x to the 5th.
It'll be x7.
X to the 7. That's it. -1.4 times x to the 7. We are psychedelic. All right. C. How about -1/3 x to the 5th multiplied by -2/9 x? Coefficient times coefficient. Right. So that's -1/3 times -2/9. Negative times a negative is a positive. So it's like 1/3 times 2/9 is 1 times 2 is 2, and 3 times 9. 3 times 9?
Oh, 27.
27.
27. So it's 2/27. X to the 5th times x.
Wouldn't that be x4?
Be careful.
I'm just saying because of the x. Wouldn't that just be add as like a 1?
Is
Uh-huh.
it 6 to the 6th power?
Right, because when you multiply, you should be adding, not subtracting, right?
I thought once you're I thought like when you have that sort of like division, like I thought you're subtracting.
You talking about the fraction there?
Yeah.
So you got to treat the coefficients separately from the bases.
Oh, yeah. Okay.
Yeah, separate. So that's still adding there. And Merry Christmas. It's 2/27x to the 6th. Colorful, isn't it? All right. What can we say? Let's turn the page. We can say that when multiplying a monomial, that's a one-term polynomial, right? A monomial by longer polynomials, you should apply the distributive rule. Apply the distributive rule. So we are ready for example 2. Find each product. A. Suppose we have 5x multiplied by 2x cubed plus 6. Five x multiplied by 2x cubed plus 6. Okay, so we have a monomial there multiplied by a binomial. And we have to apply the distributive rule. Anytime we multiply by a polynomial that's bigger than a monomial, we have to apply the distributive rule. So that's going to be 5x times 2x to the third, and then 5x times the 6. So the term on the outside has to get multiplied by each and every term inside. That's the distributive rule, right? Okay, so first, 5x multiplied by 2x cubed. Well, 5 times 2 is 10.
X to the 4th.
X to the 4th, right?
Plus 30x.
And then 5x times 6 is plus 30x. Good.
So is the answer 40x to the 5th?
Are these like
Or
terms?
no, oh, wait, no. We're not multiplying them. That's where I got confused. Okay,
And these are not like terms, right?
yeah.
10x to the 4th. Okay, so we can't add them. If they were like 10x to the 4th and 30x to the 4th, then we could say 40x to the 4th. But they're not like terms.
Okay.
So that would be the answer. Any questions with that? Let's see. Another one.
I would just say it's actually it's kind of interesting seeing 5x times 6 would be like 30x. Because you're adding another x.
So that does make sense, right?
Yeah, I'm just saying
Yeah.
you know.
Okay. Good. Okay. Like 5 apples times 6 is 30 apples. All right. B. Negative 3x squared multiplied by 5x squared plus 6x minus 1. So now the more minus signs or negative signs you have, the more likely you are to make a mistake. So you have to be really, really careful around the negative signs. And remember, I kind of treat the negatives and minus signs as the same, okay? If you see a minus sign in front of a term, treat it as the negative for the term that comes after the sign, okay? All right, so let's see. So negative 3x squared is going to get first multiplied by 5x squared. So we got to say negative 3 times 5 is negative 15. And x squared times x squared gives us
X to the 4th power.
x to the 4th. Good. First term done now. Negative 3x squared multiplied by the second term.
Negative 18 or minus 18. X to the 3rd power.
Good. And then negative x squared multiplied by the negative 1
Plus 3x squared.
plus 3x squared. And that is it. No like terms, so you can't combine any of those. And the terms are in descending order, right? Isn't that nice? Any questions with that? Pretty straightforward, I would say. Yeah. Yes, indeedy. Okay. So now we can take it next step higher. Way easy. Uh-huh. Okay, let's take it to the next step. When multiplying long polynomials by long polynomials, it may be helpful to multiply in a format similar to multiplication of whole numbers. Okay. So there's several ways you can multiply long polynomials with long polynomials. You could distribute everything. That's one way. But a nice way to do it, I think, is in a similar format to multiplying regular whole numbers, where you line one on top of the other and then multiply like the ones place, the tens place, then the hundreds place. And each time you go to the next place, you shift over and get multiplication. So let's see how that's done in example 3. This says, I'm debating, should I do it on the next page? Let's see. Okay, we'll see. Maybe we'll continue on the next page. Let's see. Multiply the following. So we have 3x plus 2 multiplied by 2x minus 5. So when I say multiply similar to whole numbers, I'll show you what I mean. So let's see. So line them on top of each other. 6 squared minus 10. Be careful. So 3x plus 2 multiplied by 2x minus 5. So let's say like this is like a 2-digit number multiplied by a 2-digit number. Remember, polynomials mean many numbers. So they're really numbers and disguised. Okay. All right. So we know that when we have like a 2-digit number multiplied by a 2-digit number, we start with the ones place, right? This times this, and then we do this times this, and then we shift over the second row, and we say that the hundreds times that, and then that times that. So we're gonna do the same thing, similar. Only thing is we don't do any carrying over, right? Okay, so let's get ready to rumble. Here we go. So -5 times +2. You got to keep track of the signs as you go along. So that's -10, right? And then -5 multiplied by 3x. -5 times +3x should be -15x. And then the 2x has to get multiplied by the top polynomial. So 2x times +2 is 4x, and you can line up the like terms. And finally, 2x gets multiplied by 3x. 2 times 3. By the way, the 4x was positive. 2x times 3x. 2 times 3 is 6. And x times x, don't forget the invisible ones, gives you x squared, right? And then we can add this up. The nice thing is you don't have to go from right to left. You can go from left to right if you want. So you get 6x squared. -15 plus 4 is minus 11x. And bring down -10. This would be your answer. How you like that? Everybody see what I did? I kind of patterned it after regular multiplication of whole numbers, like a 2-digit number times a 2-digit number. It's interesting that when you shift over to the second place, that you shift down here too, so that the like terms line up. Andrew, yeah, you spoke too soon. Now, has anybody heard of FOIL? Anybody heard of FOIL?
Yes.
Ah, what does
Like a FOIL equation?
what does FOIL stand for?
Uh,
An acronym.
yeah, first, outside, inside, last.
Okay, first. Okay, so that stands for first. So first, I like to say, you say outside. Okay, we'll use outside. Then inside or inner, outer and inner you can use, but outside, inside, last is okay. So the whole point is the F in first means you multiply, if you have the two binomials side by side, you multiply the first term on this side by the first term on this side. So that'll be 3x times the 2x. That'll represent the first terms. The O outside, you're going to multiply the outside terms together. So the outside terms will be the two terms that are on the extreme. The left extreme term times the right extreme term. That'll represent the O in FOIL. And then The inside terms will be the inner terms, the two inner terms. That would be the I in the FOIL. And then the L, the last term. So the last term here times the last term here. That'll be the L. So in other words, the 3x times the 2x is 6x squared. That's the F. The O is the 3x times the negative 5 is minus 15x. The I inside term is the 2 times the 2x is plus 4x. And then the last, the 2 times negative 5 is minus 10. And the two terms in the middle are like terms, so you can combine those together to get 6x squared minus 15 plus 4 is minus 11x minus 10. So that's an alternative way of getting the answer. So FOIL is a way just to think about multiplying. But when you FOIL, all you're doing is distributing all the terms on the left side with all the terms on the right side. You're distributing the 3x with the 2x and the 3 with the 5, not minus 5, the F and the O. And then you're going to the 2 and distributing the 2 with the 2x, that's the I, and the 2 with the negative 5, that's the L. So all you're doing is multiplying, you're distributing everything on the left with everything on the right, but FOIL is just a way that you can remember that, if that helps. But when the polynomials are long, I definitely prefer to do it patterning it after old-fashioned arithmetic. So let's see another example. B, gotta turn the page for that. Turn the page for B. So B, we have 2x minus y squared. You gotta be careful with that. Some people would just think it's, oh, 2x is gonna be squared and the minus y is gonna be squared. But you have to be careful, right? So what?
Won't that be 2 x and then the coefficient would be 2?
Is it 4x?
So the first thing you need to do, so you don't fall in any of the pitfall traps, is that 2 on the outside, the exponent. What does the exponent mean? Well, remember, back to basic rule of exponents. It means you multiply everything inside by itself 2 times. So that means you have to do, I don't know why all these marks are getting all over the screen, but anyway. That means you're gonna have to do the 2x minus y multiplied by itself 2x minus y 2 times. So you have to be careful when the exponent is outside of a polynomial. Inside, you're actually gonna have to drag it out the amount of times whatever the exponent is, okay? So that you won't make a mistake. All right, so now that we've done it like that, I could quickly FOIL it or distribute it to get the answer. So I can do the 2x with the 2x times 2x is going to give me 4x squared, right? Don't forget your invisible 1 exponents. If you have to write them in, then write them in, right? If you have to put a 1 there and a 1 there to remember that they're there, so that you have to add them. All right, 2x times 2x. Next is 2x times the negative y. So 2x times negative y gives me negative 2xy. I like to put the letters in alphabetical order when I multiply them. All right. Next, we're going to distribute the negative y. So we have negative y times 2x. Again, we're going to have another negative 2xy. Put the letters in alphabetical order, right? You can move the letters around when they're multiplying. What rule is that? What rule says that you're allowed to change the order of the multiplication and still come up with the same answer?
Commutative.
The commutative rule, very good. So the commutative rule of multiplication allows us to switch the order around to make them the same. I look the same, so I switch them to alphabetical order. All right, and then negative y multiplied by negative y. A negative times a negative is a plus y.
Squared.
Right, squared. Don't forget those invisible ones. Good. Are we finished yet?
No,
Okay.
we have to add the -2 plus the -2, or -2xy. Yeah,
Okay.
those two.
Those are like terms, huh?
Mhm.
Okay. You always gotta combine like terms. That's just like simplifying your fractions. You always gotta reduce your fractions in order to be correct. Same thing with polynomials. You always gotta combine like terms in order to be correct, to be simplified. All right, so this will give us 4x squared. These -2 is going to
Isn't -4xy?
good. I'm glad you didn't say plus 4xy.
Mhm.
Common mistake.
Change.
Uh-huh. Plus y
Y
squared.
squared.
Right? Just bring that down. And that'll be your answer.
So Professor, would the FOIL method work if the problem was 2x minus y cubed?
Let's see, 2x minus, oh wait, 2x minus y cubed? Oh, that's a good question.
So the same format where it's instead of squared, it's cubed.
Since you brought it up, let's make that problem C. Thanks for more work for the class. Yay. Okay, just kidding. Okay, so 2x minus y cubed, right? Is that what you're saying?
Yes.
Okay, good question. So you have to really be extra careful with that. So again, literally always write it out that amount of times. Okay, so third power means you gotta write it out 3 times. So 2x minus y multiplied by 2x minus y multiplied by 2x minus y. So that's the first step. Before you do any kind of multiplications, you're gonna wanna write them out. Literally that amount of times, whatever the exponent is, right? Okay, now, when we multiply polynomials, we can only multiply two polynomials at a time. Only two polynomials at one time. Okay, so don't do anything silly like 2x times 2x times 2x. Stick with two polynomials at a time, get the answer, and then multiply by the next polynomial. Okay. All righty then. Well, good thing is we already know the answer to 2x minus y times 2x minus y because we just got it. We just have it right here. So that tells us that this is equal to Megan must be tapping the keyboard. All right, so 2x minus y times 2x minus y gives us 4x squared minus 4xy plus y squared, right? All these marks all over the screen. Multiplied by 2x minus y. And now, now what? Now, we need to multiply a trinomial times a binomial. So this is the way I'm going to do it. I'm going to take the longer one, put it on top. So let's take the 4x squared minus 4xy plus y squared. And underneath, I'm going to put 2x minus y. So that this will pattern like old school multiplication, like a 3-digit number multiplied by a 2-digit number. And I'm going to do it like that. Now you can kind of distribute if you like. You could distribute everything here with everything over there. So you would have 3 times 2, you would have 6 multiplications to do there. All right. The only thing with doing it across like that is you could get kind of lost with the exponents, but it could be done that way. So I like to do it this way. So here we go, starting from the right. Negative y multiplied by positive y squared. It's going to give me y cubed, and positive times negative is a negative. Got to keep track of the signs and put it in front of the term. Then negative y multiplied by negative 4xy, right? Negative times negative, right? That's going to give us a positive 4xy squared. Good, good. And that's positive. And then negative y times 4x squared is going to give us a negative 4x squared y. So the top row is done. Okie dokies. Next we have.
I'm kind of confused, Mr.
Mhm.
Gaines. What's it called? Did you add the xy squared because it's by itself?
Yeah, so remember, if it doesn't have an exponent, it's invisible ones there, right?
Right, but
So
I was looking at the 2x and the 4xy like from top, and I thought it was like we're subtracting the.
no, this is a multiplication. I put the dot there for multiplication. Put that big fat dot right there.
Oh, okay. Yeah, I see it.
So it's like multiplying a 3-digit number by a 2-digit number. And that's what I pattern after. So I did the negative y multiplied by a positive y squared, got negative y cubed. Then I did the negative y multiplied by the middle term, negative 4xy. I got plus 4xy squared. And then I did negative y multiplied by 4x squared. Give me the negative 4x squared y. Now the second row. Focus, focus, focus. All right, so 2x multiplied by the plus y squared. Positive times positive, that's going to give me a positive 2xy squared, right? A positive 2xy squared.
So,
What?
Mr. Gaines,
Uh-huh.
we're still pretending that there's a 0 right below that negative y cubed, correct?
Negative y cubed. What right. Exactly. It's like a 0 there. Like with old-fashioned multiplication, right? And we shift to the next column. The nice thing about this, it doesn't always exactly have to work out like this, but most times it does work out that the like terms, it would shift over automatically. And so you can see that, oh no, I'm not going to put the 2xy squared under the y cubed because they're not like terms. I'm going to put it under the 4xy squared because they're like terms. So in most cases, it'll line up nicely like that. And it patterns old school multiplication. Isn't that nice? All right, back to where we were. Okay, so we just did 2x times y squared gave us positive 2xy squared. Now we're up to 2x multiplied by the negative 4xy. Okay, let's focus. So 2 times negative 4 is going to give me a negative 8x squared y. Well, how nice. It lines up nicely as a like term. And then finally, the 2x is going to get multiplied by 4x squared. And that will give us a
Positive 8x cubed.
positive 8x cubed. Good. And let's add this up, see what we get. So we get 8x cubed, negative 4, negative 8.
Minus 12x squared y.
Good. And 4 and 2.
Plus 6x y squared.
Uh-huh.
Minus y cubed.
That's it. You got it. Now, who brought this problem up? Who gave us all this work to do? Who was that?
But boy, was it worth it.
Who's that, Daniel?
Yeah, that's me.
Oh, okay. It was worth it, you said. Uh-huh. So that was a good question. Okay. A common mistake when you show distributive as well. Okay, we could do distributive. What a common mistake would be to say 2x to the third power. It's going to be 2x times 2x times 2x. You're going to get the 8x cubed. And then the minus y gets cubed. So you're going to have the minus y cubed. So people would just say, oh, the answer is just 8x cubed minus y cubed. Doesn't work like that because of the polynomial inside. So polynomials, you have to drag them out each in individual as individual factors. Okay.
Be careful.
Be careful, right? Only way you can get away with that if you had a monomial inside, right? If you had something like 2xy cubed, right? That's a monomial, one term. Now you can say, oh, 2 is going to be cubed, 2 times 2 times 2, that's 8. X is going to be cubed, and then y is going to be cubed. So that's just 8x cubed, y cubed. So that only works for monomials inside the parenthesis. But if you have longer polynomials than one term, you got to drag them out. So Andrew said, well, I show the distributive way. Okay, so let's distribute. Let us take this row and multiply it out sideways. Okay, so let's do for those who are halfway paying attention, this is a this was a sidebar here, just in case you just tuned in. That's a little separate. That has nothing to do with this problem. So we want to work this problem again from the distributive point of view. So let's do 4x squared minus 4xy plus y squared times 2x minus y. Let's distribute everything and see what happens. Although it'll be better to have the shorter polynomial on the left, but let's just do it like this. See what happens. So we have 4x squared times 2x. We have 8x cubed. We have 4x squared times negative y. We have minus 4x squared y. Then we have minus 4xy times 2x. So that's going to give us negative 8x squared y. Can I just line up my like terms as I go along? Negative 8x squared y. It'll save you some work. And negative 4x y times negative y. That'll give us negative 4x y.
Isn't it a positive because the y is negative?
Thank you. Plus 4x y squared. Thank you for paying attention. I like that.
I still-
Yay.
Professor, you lost me on the first outer inner last. I don't know, where did you get the negative 4x squared y?
Okay, so I did the 4x squared times the 2x. That gave us the 8x cubed, right? And then I did the 4x squared times the negative 2. I'm sorry, 4x squared times the negative y. 4x squared times negative y.
Oh, okay.
So that gave me negative 4x squared y. Right?
Yeah.
So I'm taking each term on the left and multiplying by each term on the right.
Oh, okay, gotcha.
And now I did the negative 4xy times the 2x, and I got negative 8x squared y, right?
Yes, now we have to do distribute the y squared.
So now we're up to the y squared, right? The
Yes.
y squared times 2x is 2xy.
2xy squared.
Okay, good. 2xy. And I'm gonna line up my like term to, let's make it all black. 2xy squared plus. And let's, one more, right? The y squared. See why I like the other way better?
Is it negative y cubed?
Right. Negative y cubed. Negative. Of course, you don't have to put the arrows there, but still, you want to know where you are, right? So line them all up, add them all up, you get 8x cubed minus 12x squared y plus 6xy squared minus y cubed. So what distributor you want to put there? That is correct. Andrew says, so with distributive, you want to put the smaller polynomial to, yes, it'll be easier if you put the smaller polynomial on the left. The 2x minus y in front of the 4x squared minus 4xy plus y squared, because this is too much back and forth like that. But they're the same answer, right? Yay. Yay, yay, yay. But see, why I like this way better, that patterns after arithmetic multiplication, is because when you multiply, the like terms kind of line up themselves, you know, following the old pattern of multiplication of whole numbers. Okay, let's do one more together. And then I'll give you a few problems to do on your own. So which one should I do? So these can get complicated, but you got to stay focused. I lost what example we were up to since we threw in, we
I
improvised.
think this is D.
Should be D. Should be
Well,
D.
well, the one we just did is D, right? The distributive one, even though you didn't name it.
I did C. The last thing I did was a C. What did we do before that?
We're on example 3.
So I'm gonna say example 4. Let's start out with a clean example 4. Example 4, because it's gonna be a hard one. Example 4. Since we are good at this now, we're ready for a hard one. Let's find the product of 2x squared minus 3x plus 4 and x squared plus 5x minus 2. Not so bad. Not so bad, is it? Zion is here, yay. We're gonna make him co-host. Yay. All right, so, okay. So last problem together, and then we're gonna work them in groups. All right. My iPad is running down. All right, so here we go. We're gonna multiply them. You know how I like to multiply them. I like to line them up like old school. Old school arithmetic multiplication. 2x cubed 2x squared minus 3x plus 4 on top. And right underneath, I'm going to put x squared. Let me see. Too many marks. X squared plus 5x minus a 2. I am not adding these polynomials. Please pay close attention. All right. I am multiplying. I better write that. Multiplying. That's my big dot for multiplication. Okay. Just in case your brain tuned out and you tune back in. We are multiplying like old school. Children must be playing across the keyboards tonight. All right. So, Megan, I hope you can stay focused with all that background noise. All right. So, here we go. So, it's like a 3-digit number, whole number multiplied by a 3-digit whole number, right? That's how I do it. So, here we go. Ready, set, go. Start from the right. The -2 multiplied by +4. Negative times positive. Negative 8. 8 for those who are not bilingual. Okay, -2 times -3x. Negative times negative is a +6x. -2 times +2x squared. Negative times positive. -4x squared. I forgot to put the what? What did I forget to do? What did I forget to do? What did I leave out? Somebody tell me, what did I leave out in the first row?
The plus sign, plus 6x.
Thank you. Remember, you have to have a plus or a minus sign in between every term in a polynomial, okay? The only time you don't need to put the sign is if it was the term in front and the term in front is positive. That's the only time you don't have to put it. Other than that, if it's anywhere else, you have to put the plus and the minus. And if it's in the front and negative, you got to put the negative in front.
Wait, how did you get a +6x? I got a -6x.
I did,
What did I do?
I did, where's my magic wand at? Here it is.
-2 times -3x.
Oh, there it is. Okay, got it.
All right, good. Now we're cooking with gasoline. All right, so next row, please. Sure, why not? Okay, so 5x, we're shifting to the 5x, and then we're gonna multiply the top row again from right to left. Okay, so 5x times +4, that gives me plus
20x.
Thank you, plus 20x. I'm not gonna forget the sign this time, right? Plus.
Right.
All right, plus 5x multiplied by -3x or -3x, whatever you want to call it.
-15x squared.
Good. -15x squared. Thanks for the help. And then +5x multiplied by 2x squared.
10x cubed.
10x cubed. Because it's positive and it's in front, I don't have to put the plus in front, right? Good, 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 good. Now to the x squared term. X squared multiplied by the +4 gives me plus 4x squared. Is that true?
Yes.
Good. All right. Okay, so now x squared times -3x gives us, how much is that?
Negative 3x cubed.
Very good. Negative 3x cubed. Okay, you can get lost here if you don't stay focused.
Mm-hmm.
Focus, focus, focus. You have to take some focus factor. Just playing. All right, x squared times 2x squared is
2x to the 4th power.
2x to the 4th power. That's positive. Good. Whew, we're done. Oh, that took a lot out of me. All right. Last step, of course, is to add up and down, right? So we have 2x to the 4th. 10 minus 3 is a plus 7x to the
3rd or cubed.
good. All right, now we got minus 4, minus 15, same sign I add. So that's minus 19 plus 4 gives me
Negative 15x squared.
You want to see a little trick there? What's the little trick there?
The 4's cancel out.
Right, they cancel out. So you just bring down the negative 15x squared. How you like that? All right, 6 and 20. No, that's easy because they're both positive. 26x and minus 8. Woo! So we got 2x to the 4 plus 7x cubed minus 15x squared plus 26x minus 8. Yay! Now you see why we're only doing multiplication tonight. Because you gotta get it. This is important. You gotta get it. You got to get it. All righty. All right. So we got practice problems to do, pages 336 to 337, 8, 16, 18, 24, 30, 40, 44, and 52.
All right, so let's get started with number 8. And before we get on with this problem, are there any questions involving the material? Okay. So for this problem, it doesn't matter which way you start. So you can start pairing these two or these two. So I'm going to choose x and 5x to the 4th. So if we multiply monomials, the constant terms just go to the side and multiply with each other. So x is the same thing as saying 1 times x. So 5 and 1 are our constants, so we have to multiply them together. So 1 times 5 is just 5. And then we'll have x times x to the 4th. So using the addition rule for powers, what would that be?
X to the 5th.
Perfect. So now we'll have x to the 5th times negative 6x to the 7th. So what would the constant term in this monomial be?
Negative 30.
Perfect. And then x to the 5th times x to the 7th?
X to the 12th.
Perfect. Any questions? Okay. So what were the questions? 16. So number 16. So we have negative 4b squared times 3b cubed minus 12b squared minus 6. So for this problem, we just utilize the distributive property. So we have to multiply this with this, this, and this. So let's take it one at a time. So we'll just have negative 4b squared times 3b cubed. So what would that be?
Negative 12b the fifth.
Perfect. And then what happens when we multiply negative 4b squared times 12b squared?
It'd be
Positive
positive 48b to the fourth power.
Perfect. And then how about minus 4b squared times negative 6?
24b squared.
So positive 24b squared. Any questions on that? All right. So let's see. Our next problem is problem 18. So this also applies an application of the distributive property. So we'll have 6y cubed minus 5xy squared. 6 squared y. And then minus 5x cubed. So if we have negative x times 6y cubed, what would that be?
negative 6xy cubed.
Perfect. And then what about negative x times negative 5xy squared?
That'd be positive 5x squared y squared.
Good. Minus x times x squared y.
Negative x cubed y.
Perfect. And then lastly, minus x times 5x cubed.
Plus 5x to the fourth.
Oh yeah, minus, forgot. So then plus 5x to the fourth. Are there any like terms we can combine?
Nope.
Okay, good. That's our final answer. So any questions? Okay. So next up is 24. So now we'll be doing y minus 10 times y minus times y plus 11. So we can FOIL it out, or we can do just the distributive property twice, which is basically foiling. So let's try foiling it out first. So y times y.
Y squared.
Y times 11.
Plus 11y.
And then negative 10 times y.
Negative 10y.
Y.
And then negative 10 times 11.
Negative 110.
Good. Any like terms?
Yes, the
Yeah.
11y and 10y.
What does that become?
Y.
Just y.
So plus a y minus 110. Sound good?
Yep.
Cool. Let's do number 30. So number 30 asks 6x minus 7 squared. So if we're squaring something, it's multiplying it by itself twice. So we'll have 6x minus 7 times 6x minus 7. So let's FOIL it. So let's do 6x times 6x. So what's that?
36x squared.
Mm-hmm. And then 6x times negative 7.
Minus 42x.
Perfect. Negative 7 times 6x.
Again, minus 42x.
Mm-hmm. Multiplication is commutative, so it doesn't matter which order you go in. And then negative 7 times negative 7.
Positive 49.
Perfect. And then what happens here?
Combine like terms.
Yeah.
So when we combine them, what happens?
Becomes
You get
negative
84.
Mm-hmm. Well,
Well, a
minus
negative
84.
84x.
Mm-hmm. And this is our answer. Questions?
Yeah, if I do it like the traditional 6x minus 7 and then I go under 6x minus 7, that'll work too, right? I didn't get to finish this one on my own, but that would work, right? Instead of the way you're doing a FOIL method.
Yeah, that's how I did it.
Yeah.
Oh, cool.
Yeah.
Okay. That's probably how I'm gonna do it. Okay, thank you.
So let's see, number 40. So we have a plus 2 times a cubed minus 3a squared plus 7. So how should we start this problem? How are we going to multiply the a's? And
By
then
adding
how are we
them?
going to... Yeah, so we're just going to add the a to, multiply the a to everything, right? And then add. And same thing with the 2. So let's see. What's a times a cubed?
A to the fourth power.
Mm-hmm. And then a times negative 3a squared.
Negative a cubed.
Well, negative 3a cubed.
That, yeah, 3a.
Mm-hmm. And then a times 7 is just
Positive 7a.
Mm-hmm. And then what about 2 times a cubed?
2a cubed.
Mm-hmm. And then 2 times negative 3a squared?
Negative 6a squared. Plus 14.
And then 2 times 7? Good. What are the like terms we can combine?
The negative 3a cubed and the positive 2a cubed.
Mm-hmm.
That's
Is there anything else?
a cubed. No.
Perfect. So we'll have negative a cubed. And just bringing it in terms of ascending powers, we'll do 6a squared plus 7a minus, plus 14.
Mm-hmm. That's what I got.
Cool. All right, so we'll do number 44 now. So now we have y minus 1 times y minus, whoops, skipping a step there. We have y minus 1 cubed. So how can we expand this?
Y minus 1 times y minus 1 times y minus 1.
Mm-hmm. So let's take it one step at a time. What's y minus 1 times y minus 1? So let's see.
Okay.
Y
So-
squared minus y is what I did for the first one.
Mhm.
And then,
Okay.
I don't know if I did this right. And then I did, the second one would be minus y plus 1.
Mhm.
So then that y squared plus 1 times y minus 1. Oh, I did that.
Well, wouldn't it be a minus 2y because there's two y's in the negative?
Oh, yeah. So, okay, so see, I did that wrong.
What's that hissing sound I hear in the background?
Would it sound like crickets?
Yeah, it's probably crickets.
It feels like someone has the same device, like two devices together, and it's starting to become like some sort of like echo.
Okay, I'm gonna mute. Tell me if it's me.
Yeah.
It's you.
I literally have crickets back like outside the window. Okay, sorry.
That's pretty funny. Okay, so let's get back to it. So with distributive property, alongside commutativity of multiplication, it doesn't matter if I distribute to here and here, or I say, okay, we're going to distribute the y to everything. The right side to everything. So how about we distribute the terms from the left side to the right? So let's multiply y squared times y and negative 1. So what's y squared times y?
Y cubed.
Times negative 1?
Minus y squared.
Mm-hmm. And then we'll start off with a negative 2y now. So negative 2y times y?
Negative 2y squared.
Mm-hmm. Times negative 1?
Plus 2y.
Good. And then we have 1 times y and 1 times negative 1. So 1 times y is just y, and then 1 times negative 1 is just negative 1. Are there any like terms?
Yeah, you can do the cubed y's and the two y's that have no exponent.
Mm-hmm. So we'll combine these and these, right? So we'll get negative 3y squared plus 3y minus 1. Does that sound good to everyone? All right, so now we're at our last problem, problem 52. So we're going to multiply a trinomial with a trinomial. So we can continue doing it through a FOIL fashion, or I can show you how to do it with a table. Would you guys like to see how to do it with a table?
Yes.
Okay, so essentially what happens with the table, so there's 3 things in each one, so we'll create 3 rows and 3 columns. So what happens is that we'll just write down this polynomial regularly. So we'll have a 3x squared, and then a minus x, and then a positive 2. And then this one we'll write as our columns. Well, this is our columns, never mind. So as our rows. So we'll start off with x squared and then 2x and then 1. So now we just multiply each term times each term in the row. So all the rows and columns get multiplied by each other. So what's x squared times 3x squared?
3x to the fourth.
Mm-hmm. X squared times negative x.
Negative x cubed.
X squared times 2.
2x squared.
And then we'll start over. So how about 2x times 3x squared?
6x cubed.
Mm-hmm. Then times negative x.
Negative 2x squared.
Mm-hmm. Then times 2.
4x.
Mm-hmm. And then now it's just 1 times everything, right? So 1 times 3x squared is just 3x squared. And then 1 times negative x is just negative x. And then 1 times 2 is 2. So now the way we finish this problem is that we add everything together in the diagonal. So we'll add these together. And once we finish that, we can add them all. So let's start off with, so we already know that we have a 3x to the fourth. What's 6x cubed minus x cubed?
Plus 5x cubed.
And then 3x squared minus 2x squared plus 2x squared.
3x squared.
So, because 2x squared minus 2x squared is just 0. So plus 3x squared. And then minus x plus 4x.
3x.
So plus 3x. And then we just add the 2. Which method do you guys prefer? I've seen a lot of high school students use this, so that's why I wanted to bring this up.
I actually really like the table method.
Yeah, that's nice. That's
Okay.
cool.
Yeah, I like the table method.
It's a lot faster. Like,
Especially if you get to like 4 terms or stuff like that, it's definitely a lot faster.
Which ones did you add diagonal? Like the first set? Can you circle? Okay, thanks.
And notice how the diagonals have the same powers. So x cubed, x squared, x.
Is it weird that I like doing it the long way for the work?
For the work.
Yes.
That's interesting.
What they
Oh
say
no,
to
I
you.
like making my mind work harder.
I mean, different strokes for different folks. That's what my Calc 3 professor told me.
I liked doing it the long way at first because it seemed easier, but I like this table too. I just got lost with the diagonal part. It's pretty cool.
Yeah, another way to remember it is just you add everything in the table together. So you'll eventually find like terms and then, yeah.
Okay. Cool.
Cool.
Thank you, Zion. That was great. Anybody have any more questions?
That confused me.
Oh no, where did I lose you?
Just the diagonal portion of everything that we're trying to add.
Yeah, so basically what I'm doing is that I'm emulating just multiplying the 3x squared times the x squared times the 2x times the 1, right?
Right.
So that shows up here, right? Because 3x squared times x squared is 3x to the 4th. I'm just going to erase the diagonal right now. And then we'll have 3x squared times 2x, and that's just 6x cubed, right?
Right.
And then times 1 is just 3x squared. So now we'll multiply negative x times all of the right side. So negative x times x squared, that's just negative x cubed.
Right.
And then times 2x, that's just negative 2x squared, right? Are you following me with this, or is it how I got to the diagonal?
Yeah, where you got to the diagonal part, I'm following you now.
Okay, so essentially what happens in the diagonal is notice how they're all the same power.
Right.
So they'll be like terms. And if we're gonna add everything, we might as well add the like terms together at one go, right?
Right.
So if we'll have a 6x cubed and a negative x cubed, that's just gonna be a 5x cubed, right? I'm gonna use a
Yeah,
different
okay.
color.
All right.
And then same thing here. So we'll all have our x squared terms here. So we'll do 2x squared plus negative 2x squared, and that's just 0, right?
Uh-huh. Okay, all right. I see where you're at.
Mhm.
Just the way
And
it's
then you
lined
just
up.
continue
Okay.
from there, right?
Right.
And then you'll have 4x minus x, and that's just 3x. And then at the end, you'll just add the 2 and the 3x to the 4th.
Okay.
You know,
All right.
it's kind of funny the way you did it on Zion, because when I see this, it kind of reminds me of like bingo or something. I don't know.
Bingo. That's interesting.
Either that or like those, that those battleship game where
Oh,
you put
battleship,
seven.
yeah.
Tic-tac-toe.
Oh yeah, tic-tac-toe. Totally. Tic-tac-toe for sure.
And then
Very
I have to show
interesting,
you
isn't
guys
it?
ultimate tic-tac-toe,
Oh.
which is a tic-tac-toe within tic-tac-toe.
Oh.
That's probably for another day.
What's that?
Zion,
Yeah.
what's your IQ?
I honestly don't know. I don't think IQs are worth measuring.
Oh, interesting.
That's interesting. I'm gonna stop the recording.